that if the greatest minds in Europe were right about the vacuum, why could a 24-year-old with a barometer prove them catastrophically wrong? Picture this. It's 1647, and the most prestigious scholars in France, Jesuits trained in the finest universities, masters of Aristotelian philosophy, defenders of 2,000 years of scientific consensus, are telling you that empty space is impossible. Nature itself, they insist, abhors a vacuum. It's not opinion. It's settled science. Aristotle proved it. Thomas Aquinas confirmed it. Every educated person knows it. Then a sickly young mathematician named Blaise Pascal hauls a glass tube of mercury up a mountain and destroys their entire worldview in one afternoon. You know what makes this story absolutely riveting? It's not really about vacuums. It's about something you're wrestling with right now, whether you realize it or not. How do you know what's true when experts disagree? When credentials clash with evidence? When the entire establishment tells you one thing, but the data whispers something else? Pascal faced this exact dilemma. The Jesuit scholars weren't idiots. They were the intellectual elite, the Harvard professors of their day. They had every reason to believe what they believed. 2 millennia of the smartest people who ever lived backed him up. And Pascal? He was nobody. A 24-year-old with chronic migraines and a radical idea. But he had something they didn't. A method for discovering truth that didn't require anyone's permission. The vacuum controversy wasn't just a scientific spat about air pressure. It was the birth of a revolutionary idea that you use every single day without realizing it. The idea that evidence beats authority, that you can test claims yourself. That expertise means nothing if it can't survive experimental verification. Sound familiar? You're living through the exact same battle right now. COVID policies, climate science, gender ideology, economic theories. Every week, credentialed experts tell you things that your own eyes seem to contradict, and you're stuck asking Pascal's question, who do I trust, the consensus or the data? If you've ever felt intellectually bulldozed by the experts, say, if you wonder whether questioning consensus makes you a conspiracy theorist or just intellectually honest, you're asking the same question that tormented Pascal. Here's what you're about to discover. Pascal didn't just win an argument about vacuums. He pioneered a method for thinking that cuts through credential worship and appeals to authority. A method that works whether you're evaluating scientific claims, political promises, or religious teachings. In the next 15 minutes, you'll witness how a fragile young genius took on the entire European intellectual establishment and won. Not through rhetoric, but through replicable experiments anyone could verify. And you'll learn the precise methodology he used, so you can apply it to every contested truth claim you encounter. If you want to discover more thinkers like Pascal who refuse to bow to intellectual bullies, subscribe to this channel where we explore the minds that change how we think. Let me take you back to 1640s France. Imagine you're an educated person. You've studied at university, you know your Aristotle, you can debate in Latin. If someone asked you, can empty space exist? You'd laugh at the question. Of course not. Nature abhors a vacuum. Horror vacui. It's not debatable, it's basic physics. Here's why this belief dominated for 2,000 years. Aristotle observed that when you create an empty space, nature rushes to fill it. Suck air out of a tube, and liquid rises to fill the void. Create a partial vacuum, and surrounding matter compresses inward. Everywhere you look, nature seems allergic to emptiness. But Aristotle went further. He argued philosophically that void space is logically impossible. His reasoning? Place is defined by the boundaries of whatever occupies it. Remove the thing, and you remove the place itself. Therefore, empty place is a contradiction in terms, like a square circle. Vacuum isn't just rare. It's metaphysically impossible. You know what's fascinating? This wasn't just abstract philosophy. It solved real problems. Aristotle's physics explained why water rises in pumps, why siphons work, why objects fall. It was a complete, coherent system. That's why every educated person believed it. It worked. Fast forward to the 1640s, and this Aristotelian framework is the foundation of Jesuit education. The Society of Jesus, the intellectual shock troops of the Counter-Reformation, built their entire curriculum on scholastic philosophy, which meant synthesizing Aristotle with Christian theology. To attack Aristotelian physics wasn't just scientific heresy, it threatened the whole edifice. Notice how this works in reality. When you build an entire system on certain axioms, questioning those axioms feels dangerous, not because of bad faith, because everything downstream depends on them. The Jesuits weren't being stubborn. They were protecting intellectual coherence. Then in 1643, something happened that cracked the foundation. Evangelista Torricelli, a student of Galileo, conducted an experiment in Italy. He filled a glass tube with mercury, inverted it into a basin, and watched the mercury level drop, leaving an empty space at the top of the tube. Torricelli claimed he'd created a vacuum. But here's where it gets interesting. Even Torricelli's supporters weren't sure. Maybe subtle matter filled the space. Maybe invisible air leaked in. Maybe nature's vacuum abhorrence simply had limits, strong enough to support 30 inches of mercury, but not more. The question reached Pascal in 1646. His brother-in-law showed him Torricelli's experiment, and Pascal, already a mathematical prodigy who'd invented a calculator machine at 19, saw something nobody else did. This isn't about mercury. It's about methodology. How do we settle competing explanations when observation is ambiguous? The Aristotelian said, trust philosophical reasoning and establish authority. Pascal said, design experiments that force nature to answer unambiguously. Wait till you see what he did next, because the methodology he pioneered is the exact tool you need when experts contradict evidence. Here's where Pascal's genius exploded into view. He didn't just repeat Torricelli's experiment. He designed variations that would distinguish between competing explanations. Think about the intellectual courage required here. The entire Jesuit establishment is telling you that vacuum is impossible. They have Aristotle. They have Aquinas. They have institutional prestige. And you're a 23-year-old with health problems. What do? Pascal did something revolutionary. He stopped arguing and started testing. His first insight: if the space above the mercury is truly empty, changing external conditions should produce predictable effects. If it's subtle matter, different predictions follow. Nature herself will referee the dispute if we ask the right questions. In 1646 through 1647, Pascal conducted a series of experiments in Rouen. He didn't just use mercury. He tried water, wine, oil. He used tubes of different sizes. He tilted tubes at angles. Every variation tested a specific hypothesis about what's happening in that mysterious space. You know what I love about this approach? Pascal wasn't trying to win a debate. He was genuinely curious about truth. He designed experiments where he could be proven wrong. That's intellectual honesty. Make your claims testable, then test them honestly. But the breakthrough came in 1648, when Pascal had an absolutely brilliant idea. If Torricelli was right, if atmospheric air has weight and presses down on the mercury, supporting the column, then the mercury level should drop at higher altitudes, where air is thinner. Notice the logic. Aristotelian said nature's vacuum abhorrence is constant everywhere. Pascal's atmospheric theory predicted variation with altitude. One experiment could decide between them definitively. So Pascal asked his brother-in-law, Florent Purier, to carry a barometer up the Puy de Dôme mountain in central France, 4,800 feet of elevation change. Meanwhile, a control barometer stayed at the base. If Pascal was right, the mercury column would be shorter at the summit. Imagine this scene for a moment. September 19, 1648. Purier and witnesses laboriously climbing a mountain, carrying fragile glass tubes of toxic mercury to settle a philosophical question. The absurdity of it, hauling scientific equipment up a volcano to check whether Aristotle was wrong about vacuums. The result? Exactly what Pascal predicted. The mercury dropped more than 3 inches during the ascent, precisely tracking the decrease in atmospheric pressure. At the summit, less air meant less pressure, which meant shorter mercury column. When they descended, the mercury rose again. Let me show you something amazing about this. Pascal didn't just prove vacuums exist. He proved a method, the experimental method, works better than philosophical deduction. He demonstrated that nature answers questions if you design clever tests. That evidence beats authority, that you can verify claims yourself, regardless of credentials. The Jesuit response was complicated. Some accepted the evidence immediately. Others doubled down, proposing increasingly elaborate explanations to save Aristotelian physics. A few accused Pascal of arrogance and impiety, questioning settled doctrine. Here comes the really interesting part. Pascal realized a vacuum controversy wasn't about vacuums at all. It was about epistemology, how humans discover truth. And this fight got personal. If this methodological revolution impacts you as much as it does me, hit like so more people discover how Pascal changed the rules of intellectual combat. Now we get to the heart of the controversy. What happened when Pascal's evidence collided with Jesuit institutional authority? Father Etienne Noël, a prominent Jesuit and rector of the Collège de Clermont in Paris, wrote to Pascal in 1647. His letter is fascinating, not because it's stupid, but because it's sophisticated. Noël didn't deny the experimental results. He reinterpreted them. Noël argued that the space above the mercury isn't empty. It's filled with purified air or subtle matter too fine to detect. This matter, he suggested, behaves differently from ordinary air, which explains why it doesn't press down with the same weight. You know what's brilliant about this response? It's unfalsifiable. Whatever evidence Pascal provides, Noël can always say, yes, but invisible subtle matter explains that too. It's a 17th century equivalent of modern responses like, that's just your interpretation, or science doesn't know everything. Pascal recognized the trap immediately. In his reply, he wrote something that should be etched in every thinker's mind. If explanations multiply to save a hypothesis, the hypothesis is probably wrong. He insisted on Occam's razor. Don't multiply entities beyond necessity. The simplest explanation, vacuum exists, air has weight, explains all observations without inventing invisible substances. But here's where Pascal did something even more important. He exposed the methodological difference underlying their dispute. Pascal wrote, in matters of fact, authority counts for nothing. Reasoning must yield to experience. He drew a sharp distinction between two kinds of questions. Questions of authority, covering theology, history, and law. Here, consult authoritative sources. Scripture, reliable witnesses, established texts. Questions of fact, covering natural philosophy and science. Here, authority is irrelevant. Only observation and experiment matter. Aristotle's prestige doesn't make vacuums impossible. Evidence decides. This distinction sounds obvious now. You use it automatically. You don't check Wikipedia to determine if water boils at 212 degrees Fahrenheit. You test it. But in 1647, this was revolutionary. Pascal was carving out a sphere where the church, Aristotle, and scholastic tradition had no jurisdiction. Notice how this works in reality. The Jesuits weren't being irrational. They were defending a worldview where truth flows from authoritative sources properly interpreted by qualified experts. Pascal was proposing a radical alternative. Truth flows from nature herself, interrogated by anyone with equipment and methodology. The controversy intensified when Father Noël published his views in 1648. Pascal responded with new experiments concerning the vacuum, methodically dismantling Noël's subtle matter hypothesis with further experiments. One of my favorites, Pascal sealed wine in a tube, creating vacuum above it. If subtle matter existed, it should penetrate the wine and fill the space. But nothing happened. The space remained empty. Pascal even calculated, if subtle matter existed with properties Noël attributed to it, it would violate known principles of mechanics. But here's what fascinates me most about this exchange. Both men were deeply Christian. Both believed in God. Both valued truth. Their disagreement wasn't religion versus science. It was about the method for discovering natural truth. Pascal accused the Jesuits of intellectual pride disguised as humility. They claimed to humbly submit to Aristotle's authority, but Pascal saw it differently. True humility means submitting to reality, even when it contradicts prestigious sources. Clinging to false theories because smart people believe them, that's pride pretending to be tradition. The Jesuits accused Pascal of arrogance, trusting his own experiments over centuries of wisdom. But Pascal flipped it. Who's more arrogant? The person who tests claims before believing them, or the person who demands belief based on authority alone? Wait till you see the implications of this methodological split, because it explains every single science versus authority battle you're watching today. Let me show you something that will change how you evaluate every truth claim you encounter. Pascal's systematic framework for distinguishing good reasoning from bad. In his work on the geometric spirit, written around this time, Pascal laid out a methodology that synthesized mathematical rigor with empirical investigation. He identified 3 distinct ways humans discover truth and warned that confusing them causes intellectual disaster. First, matters of fact, covering natural philosophy. Truth discovered through observation and experiment. Authority is irrelevant. Aristotle's opinions about vacuums don't matter. What matters is what happens when you pump air out of a container. The method is empirical testing with replicable results. Second, matters of reasoning, covering mathematics and logic. Truth discovered through rigorous deduction from clear axioms. No authority needed. Just follow logical steps from definitions. The method is geometric demonstration, where each step necessarily follows from the last. Third, matters of faith, covering theology and revelation. Truth received through authoritative sources, scripture, church tradition, mystical experience. Evidence and logic are insufficient. These truths transcend natural knowledge. The method is submission to revealed authority. Here's where Pascal's genius shines. He insisted we must never confuse these orders. Don't demand experimental proof for theological claims. That's category error. But equally, don't invoke religious authority for questions of fact. That's intellectual tyranny. The vacuum controversy was precisely this confusion. Jesuits treating a question of fact, whether empty space exists, as if it were a matter requiring submission to Aristotelian authority. You know what's brilliant about Pascal's framework? It protects both science and faith. Science can't disprove God, because that's the wrong order. But theology can't dictate what happens in barometric experiments, which is also the wrong order. Each domain has its proper method. Violating those methods produces nonsense. Imagine the scene for a moment. Pascal, suffering from debilitating headaches, sitting at his desk writing letters to Jesuit fathers, carefully explaining why their methodology fails. He's not attacking their intelligence. He's attacking their confusion of categories. In one devastating passage, Pascal wrote, "When we wish to correct someone usefully and show them they are mistaken, we must observe from what point of view they are considering the matter, for it is usually correct from that viewpoint. And we must admit this but show them the viewpoint from which it is false." Notice the sophisticated charity. Pascal acknowledged that from within the Aristotelian framework, Jesuit objections made sense. But that framework itself was wrong for investigating natural phenomena. The problem wasn't their logic, it was applying the wrong logic to the wrong kind of question. Let me show you how this works practically. When the Jesuits said, Aristotle and 2,000 years of scholars believed in horror vacui, they were committing an appeal to authority in a domain where authority is irrelevant. It's like saying, the greatest chefs in history believe the earth is flat, so geography must be wrong. When Pascal responded with experimental data, he was saying, your experts are irrelevant. Nature is the only expert here, and she testifies through experiments. But here's the really interesting part. Pascal simultaneously defended theology against scientific overreach. He believed passionately in Christian revelation. He later wrote the Pensées, defending faith with arguments that remain powerful today. But he insisted, Religious truth and scientific truth operate in different orders. Confuse them and you corrupt both. This is why Pascal could be a rigorous scientist and a devout Christian without contradiction. He recognized that different questions require different methods. The existence of God isn't settled by barometric experiments. The weight of error isn't settled by reading Aristotle. Here comes a part that will transform how you think about modern controversies. Pascal's three orders explain every confused debate you're watching. By 1650, the evidence was overwhelming. Pascal's experiments had been replicated across Europe. The Puy de Dôme results were undeniable. More importantly, Pascal's atmospheric theory made successful predictions that Aristotelian physics couldn't explain. But here's what I love about how this resolved. Pascal didn't win through rhetorical brilliance or political maneuvering. He won because reality sided with him. Anyone with a barometer could verify his claims. You didn't need credentials, approval, or institutional permission, just equipment and honesty. Notice how this works in reality. Bad ideas can dominate for centuries when protected by authority. But once you establish a method for independent verification, truth eventually emerges. It might take time, vested interests fight hard, but testable claims win eventually because reality is stubborn. The Jesuit establishment gradually accepted barometric evidence, some graciously, some grudgingly. By 1660, even conservative scholastics acknowledged that Aristotelian horror of vacuum was wrong. The evidence was too strong, the experiments too replicable, the predictions too accurate. But the deeper victory was methodological. Pascal established that natural philosophy must be grounded in observation, not authority. This principle became foundational to the scientific revolution. When Newton, Boyle, and later scientists built modern physics, they used Pascal's method. Design experiments, collect data, test hypotheses, let nature answer. You know what fascinates me most? The Jesuits eventually became leading scientists themselves. By the 18th century, Jesuit astronomers, physicists, and mathematicians were making cutting-edge discoveries. They embraced the experimental method Pascal championed, once they recognized its power. That's intellectual humility, admitting when better methodology defeats your position. But Pascal never gloated. He didn't say, "I told you so." Instead, he moved on to even deeper questions. If humans can be so wrong about basic physics for 2 millennia, what else might we be wrong about? If expertise doesn't guarantee truth, how do we navigate uncertainty? These questions led Pascal to write the provincial letters in 1656 through 1657, where he attacked Jesuit casuistry with the same methodological rigor he'd used against Aristotelian physics. He exposed how moral reasoning can become corrupted when clever arguments replace honest engagement with truth. And finally, in his Pensées, Pascal turned his penetrating analysis on the deepest questions. Why do we exist? What is our purpose? How should we live in uncertainty? He applied his methodological framework to theology itself, acknowledging that faith is a different order than science, but insisting that even religious belief must be intellectually honest. Here's the pattern Pascal demonstrated throughout his life. Intellectual courage means following evidence wherever it leads, regardless of consensus. It means distinguishing between different kinds of questions and applying appropriate methods to each. It means valuing truth over comfort, even when truth is unsettling. The vacuum controversy validated this approach. Pascal bet his reputation on evidence against consensus, and reality vindicated him. Let me show you something amazing. Pascal didn't just win this one argument. He modeled a way of thinking that transcends specific controversies. Whether you're evaluating scientific claims, political promises, or religious teachings, Pascal's framework works. First, identify what kind of question you're asking. Matter of fact? Matter of reasoning? Matter of faith? Second, apply the appropriate method. Experiment for facts. Logic for reasoning. Authority, carefully vetted for revelation. Third, don't confuse the orders. Don't demand scientific proof for theological claims. Don't invoke authority for testable hypotheses. Fourth, follow the evidence honestly, even if it contradicts prestigious sources. Fifth, design tests where nature or logic or properly interpreted revelation can prove you wrong. This is the methodology Pascal bequeathed to us, not just a theory about vacuums, a framework for pursuing truth in any domain. And here's why this matters desperately today. You're drowning in competing truth claims. Experts contradict each other. Credentials clash. Consensus shifts. How do you navigate this chaos without becoming either a credulous sheep or a paranoid conspiracist? Use Pascal's method. Ask, what kind of question is this? What method applies? Can I verify independently? Am I confusing authority with evidence? Now, let me show you how to apply this framework to the exact controversies tearing your world apart. Now you see the vacuum controversy in a completely different way. It was never just about whether empty space exists. It was about something infinitely more important. Who gets to determine truth, and by what method? Pascal discovered what you desperately need to rediscover. That reality itself is the ultimate authority in matters of fact. Not the most prestigious scholars, not the oldest traditions, not the most confident experts. Reality, stubborn, testable, verifiable reality. The deepest insight Pascal left us is this. Different questions require different methods, and confusing those methods produces catastrophe. When you demand scientific proof for theological truths, you corrupt both science and faith. When you invoke religious authority for testable claims, you make religion look ridiculous and science impossible. But here's the transformation. Once you internalize Pascal's framework, you can't be intellectually bullied anymore. When someone says experts agree, you ask, what kind of question is this? Can I verify it independently? Are they confusing orders of knowledge? When climate scientists say the models predict, you can ask, are these testable predictions or unfalsifiable scenarios? When economists promise policy outcomes, you can demand, show me historical tests, not theoretical models. When theologians make claims, you can discern, is this revelation I must accept on authority or a factual claim I can investigate? Pascal showed you that intellectual courage doesn't mean rejecting all authority. It means knowing which authorities are relevant for which questions. Aristotle has no jurisdiction over barometric experiments, but he might have wisdom about ethics. The church can speak authoritatively on revelation, but not on air pressure. You've witnessed how a sickly 24-year-old with a mercury tube overthrew 2,000 years of consensus, not through rhetoric, but through replicable experiments. And you've learned the precise methodology that made his victory inevitable. Design tests where reality answers, then submit to reality's verdict. This is what intellectual freedom looks like. Not rejecting expertise, but refusing to substitute credentials for evidence. Not dismissing tradition, but distinguishing between authoritative sources for different kinds of truth. Not cynicism about all claims, but rigorous methodology for evaluating each. The question isn't whether to trust experts. It's whether experts are using the right method for the question at hand. From now on, when you encounter competing truth claims, whether about vaccines, economic policy, historical events, or theological doctrines, you'll remember that Pascal taught us to ask three questions. First, what order of knowledge is this? Is a matter of fact testable? A matter of reasoning, demonstrable from axioms? Or a matter of faith, requiring authoritative revelation? Don't proceed until you've classified the question correctly. Second, what method applies to this order? Facts require observation and experiment. Reasoning requires logical rigor from clear definitions. Faith requires submission to vetted authoritative sources. Use the wrong method, and you'll get nonsense answers. Third, can I verify this independently? For matters of fact, can you test a claim yourself or examine the raw data? For matters of reasoning, can you follow the logical steps? For matters of faith, have you confirmed the source's reliability? In the coming weeks, apply Pascal's framework deliberately. When a news article claims scientists say, investigate, are these testable predictions or model-based speculations? When a politician promises economic results, demand, show me historical cases where this worked. When a pastor teaches doctrine, ask, is this clear biblical teaching or human interpretation? You don't need to be perfect. Pascal wasn't perfect. He made errors, overcorrected sometimes, remained imprisoned by some assumptions of his era, but he demonstrated something you can imitate: the courage to test claims independently, the humility to change your mind when evidence demands it, and the wisdom to use appropriate methods for different questions. When you doubt, ask yourself, what would Pascal do in my place? Not what would Pascal believe, but what method would Pascal use to investigate? There's a phrase from Pascal I can't forget, written after the vacuum controversy transformed his intellectual life. Contradiction is not a sign of falsity, nor the lack of contradiction a sign of truth. Do you feel the weight of that insight? Do you recognize how it changes everything? Pascal learned through bitter experience that smart people can confidently defend false ideas for centuries. That consensus doesn't guarantee truth. That credentials don't substitute for evidence. But he also learned the opposite, that contrarian positions aren't automatically correct just because they're contrarian, that rejecting all authority is as foolish as accepting all authority. The answer isn't skepticism, it's methodology. It's asking the right questions, using the right tools, and submitting to reality's verdict. Imagine your intellectual life 6 months after internalizing Pascal's framework. You won't have perfect certainty. Pascal never promised that. But you'll have something better, a reliable method for navigating uncertainty. You'll see through false appeals to authority with crystal clarity. And when you encounter genuine expertise using appropriate methods, you'll recognize and respect it. This channel exists to discover together the wisdom of thinkers like Pascal, people who refuse to bow to intellectual bullies, who value truth over comfort, who pioneered methods we still use today. Subscribe if you want to continue this journey. In the next video, we'll discover how Pascal applied the same rigorous methodology to the deepest question of all: how to live in a universe that seems indifferent to human meaning. See you there. And meanwhile, may you have the courage to test claims independently and the humility to accept what reality reveals.